In this video, we're going to talk about the chi-square test, specifically how to use a chi-square distribution to perform a goodness of fit test. So let's use this example problem. A school principal would like to know which days of the week students are most likely to be absent. The principal expects that students will be absent equally during the 5-day school week. The principal selects a random sample of 100 teachers, asking them which day of the week they had the highest number of student absences. The observed and expected results are shown in a table below. Frequencies, or rather, they occur with unequal frequencies, or you could say that they don't fit a uniform distribution. Now, the goodness of fit test is a right-tail test. And so I'm going to draw a graph. Now the chi-square, let me say that again. The chi-square distribution is not a symmetrical distribution. As you can see, it's skewed. This value here is known as the critical value, or rather the critical chi-square value. It separates the rejection region from the do not reject region. So this is the rejection region. I'm going to write RR to represent that. And the area shaded to the right of the critical value is going to be alpha, which in this case is 0.05. The non-shaded region is the do not reject region. So what we're going to do is we're going to get our calculated chi-square value, compare it to our critical chi-square value, and see if the calculated value lies in the do not reject region or in the rejection region. If it lies in the rejection region, we're going to reject the null hypothesis. Now let's begin by using the chi-square distribution table to get our critical chi-square value. So the first thing we need to do is determine the number of degrees of freedom, which is equal to n minus 1. N is the number of categories our data is placed in. So the categories are the days of the week, which we're using 5 days of the week. So n is 5. 5 minus 1 is 4. So we have 4 degrees of freedom. So here we have our chi-square distribution table. And in the first column, we have the degrees of freedom. In the first row, we have the area to the right of the critical value. And as we said before, the area to the right of the critical value for a right-tail test is alpha, which is 0.05. So using this column, and we have 4 degrees of freedom, so using this row, we could see that our critical value is 9.49. So let's place our critical value here. And now we need to get our calculated chi-square value. And the formula that we're going to use is this formula. It's going to be sigma, which represents the sum of the difference between the observed values and the expected values squared, divided by the expected values. And we could find this in a table. The first row contains the observed values, and the second one contains the expected values, which have equal frequency. So using this formula, here's what we're going to get. So starting with Monday, if we take O subtracted by E, that's 23 minus 20. So that's going to give us 3 squared divided by the expected value of 20. Next, for Tuesday, O minus E, that's 16 minus 20, which is negative 4. But when you square it, it's going to become positive, divided by E, which is 20. 14 minus 20, that's going to be negative 6. And next we have 19 minus 20, which is negative 1. And then for Friday, we have 28 minus 20, which is positive 8. And then we just got to do the math. So 3 squared plus 4 squared plus 6 squared plus 1 squared plus 8 squared, that's 126. So this is 126 divided by 20, which works out to be 6.3. So this is our calculated chi-square value. So let's place that value on the graph, which should be somewhere in this region. So as we could see, our calculated chi-square value lies in the do not reject region. So therefore, we're going to accept the null hypothesis that the data is the days of the highest number of absences occur with relatively equal frequencies. So this variation is not enough or not significant to reject the null hypothesis. And so that's how you could use the chi-square test. So now you know how to calculate the chi-square value and compare it to critical value in order to determine whether you should reject or not reject the null hypothesis.